Okay, let's dive into this. If you've turned on any financial news outlet lately, you've probably heard the absolute loudest, most intense panic in the market today. I mean, we are constantly being bombarded with this narrative that the whole artificial intelligence cycle is nothing but smoke and mirrors, just the next massive bubble waiting to burst and wipe out your portfolio. But in this explainer, we're going to completely strip away the emotion. We're going to tune out all the screaming pundits, and we're going to look strictly at the objective numbers. Let's see what the math actually says. To really understand the scale of this panic, just listen to what the billionaires and media pundits are saying right now. We have prominent figures like Gary Marcus basically calling the entire AI industry a scam, boldly stating that the $700 billion being poured into AI is the greatest capital misallocation in history. You've got heavy hitters from Wall Street warning of catastrophic ripple effects. So as it stands, a lot of very rich, very loud people are telling you that if you're investing in AI right now, you are holding on to a giant, incredibly fragile bubble.
So we really have to ask ourselves, are we actually in an AI bubble, or is the math telling a completely different story? Our objective here today isn't to be a cheerleader for any specific company or technology. Not at all. What we're going to do is steelman the strongest, most aggressive bearish arguments against AI that the mainstream media is pushing, and we're going to test them against pure objective financial data to see what's actually happening beneath the surface.
Let's tackle the very first major bear argument, which is the idea that AI simply has no economic moat. The argument goes that large language models, the actual brains generating the text and code, are rapidly becoming commodities. And you know what? The bears are completely right about this. The AI model layer is absolutely being commoditized, pretty much just like soybeans. OpenAI spent around $100 million building their massive model, and recently DeepSeek built an incredibly capable model for just $6 million. That massive price drop proves these models are no longer exclusive magic. They're basically just raw materials now. OpenAI's API pricing has totally collapsed over the last couple years, and open-source models like Meta's Llama are catching up really fast. But here is the critical mistake the bears make. They look at this top layer, they see falling prices, and they assume the entire AI industry is doomed.
And this brilliantly illustrates the real dynamic at play. Think of the AI economy kind of like a city's plumbing system. The AI models themselves, the LLMs, they're just the water. Sure, the water is getting incredibly cheap and abundant. But just because the water is cheap doesn't mean there's no money to be made in the pipes, the industrial pumps, the pressure regulators, and the filtration systems required to move it to millions of homes. The models are absolutely a commodity, but the physical and digital infrastructure required to run them, that is where the actual gold is buried.
Let's look at what a true infrastructure moat actually looks like, using NVIDIA as the prime example. So NVIDIA has a software platform called CUDA. It is 20 years old, and over 6 million developers use it. Thousands of optimized libraries and literally every major AI framework are built directly on top of it. If a company wants to switch away from NVIDIA's hardware, they can't just unplug it. They would have to retrain their entire engineering team, rewrite all their optimized code, and introduce massive operational risks. That deep entrenchment is exactly why NVIDIA commands a 75% gross margin on their hardware, meaning for every dollar you spend, they keep 75 cents. You absolutely do not get that kind of margin in hardware unless you have insane, unshakable pricing power. Before we look at another example, let's quickly define a key financial metric used by institutions, and that's the Rule of 40. This is a benchmark for software companies that combines their revenue growth rate and their profit margin. If a company scores over 40, they are considered to be in excellent financial health, just perfectly balancing growth and profitability. Well, Palantir, an AI infrastructure and data integration company, recently posted a Rule of 40 score of 145. That is just an astronomical number. Pair that with zero debt and $8 billion in cash, and you start to see that these infrastructure layers aren't just burning cash on a prayer. They are incredibly fortified businesses. That brings us right to bear argument number 2, which is the terrifying comparison that we're living in the dot-com bubble 2.0. The bears love to point out that the hyperscalers, the tech giants building the cloud, like Amazon, Google, Microsoft, and Meta, they are collectively projecting to spend a staggering $700 billion in capital expenditures in 2026. That's up 80% from last year's already record-breaking $400 billion. The fear stems from the massive gap between what they're spending and what they're making, since the industry is currently generating only about $50 to $60 billion in direct AI revenue. The bears see this massive gap and immediately scream that history is repeating itself. But when we actually put the dot-com era and today's AI era side by side and look at the real numbers, the comparison completely falls apart. In the year 2000, the NASDAQ traded at a price-to-earnings ratio of around 200, which means investors paid $200 for every single dollar of actual profit. Today, it sits closer to 30.
Back then, companies had virtually no earnings, no cash flow, and zero economic moats. They were building the internet purely on hope. Today, the companies building AI are posting the highest net incomes in corporate history. In 2000, businesses were burning through speculative IPO cash. Today, the hyperscalers are funding their massive buildouts using their own massive operating cash flows and investment-grade debt specifically because they have clear, proven demand signals from enterprise customers.
Just to put this financial reality into absolute perspective, let's look at one specific number, $120 billion. That single number represents NVIDIA's recent net income. That net income alone is larger than the total combined revenue of the top 10 biggest dot-com companies from the year 2000. We are quite literally not even in the same universe as the dot-com crash. These are fundamentally sound juggernauts that are just printing cash.
But wait, you might be thinking, what about the fact that AI models are getting cheaper? Won't that hurt revenue? To understand why that's actually a massive positive, we have to look at the Jevons paradox. This is a really fascinating economic concept where, as the technology becomes more efficient and cheaper, it doesn't actually decrease demand. It ironically explodes the overall demand for that resource. When AI becomes incredibly cheap, we don't consume less of it, we invent 10 new workflows, new software agents, and entirely new daily use cases. Cheaper AI means we actually need vastly more compute power and infrastructure to support this infinite new demand.
And that addresses the third bear argument, that these stocks are supposedly priced to perfection. When you look closely at the data, it's just a lazy generalization. Despite its massive run, NVIDIA has actually been trading with a forward PE in the mid-20s and a price-to-earnings growth ratio of 0.5, which traditionally indicates a stock is undervalued relative to how fast it's growing. Now, a company like Palantir with a PE over 140 is absolutely priced for perfection, but with 85% revenue growth in some sectors and a 53% net margin, the data suggests their premium valuation is backed by their current execution. So the financial panic? The math just simply doesn't support it. So, the crucial point is this. While the bears are running around screaming about PE ratios and commoditized language models, they are completely missing the actual hidden bottleneck that is threatening the AI supercycle. The real threat to AI isn't financial at all. It is entirely physical.
We are rapidly, and I mean rapidly, approaching the physical limits of our infrastructure, specifically when it comes to power availability. Just look at the massive impending spike in demand here. In 2024, data center electricity demand sat around 400 terawatt-hours. By 2034, that is projected to quadruple to a staggering 1,600 terawatt-hours. The AI sector is literally constrained not by a lack of money and not by a lack of demand, but because the physical electrical grid simply cannot keep up with this exponential growth. To really grasp how massive this shift is, consider that by the year 2030, data centers are expected to consume up to 12% of the total electricity in the United States. Just recently, that number was sitting around 4%. We aren't just talking about charging a few extra iPhones here. We're talking about rerouting a massive fraction of an entire nation's energy supply just to keep these new servers powered and cooled. The physics of this problem are just daunting. A single server rack of next-generation AI chips now requires roughly 1 megawatt of power. That is enough electricity to power 800 U.S. homes, all from just one single rack of servers. And here is the severe mismatch in timelines that's causing this bottleneck. A hyperscaler can construct a massive new data center in about 2 to 3 years, but getting the regulatory approval and physically interconnecting that data center to the main power grid, that takes anywhere from 4 to 10 years. You can build the multi-billion-dollar facility, sure, but you can't exactly plug it into a standard wall socket. You literally cannot plug it in fast enough.
But here's the thing. Rather than being a reason to panic and sell, this energy bottleneck is actually the ultimate picks and shovels opportunity for investors. History shows us that we never abandon a major technological advancement just because of a temporary infrastructure constraint. I mean, we didn't stop building cars because we ran out of paved roads. We just built more roads. The data suggests the companies that step in to solve this massive electrical and cooling bottleneck are positioned for incredible historical growth.
So who are the players actually positioned to solve this? Well, analysts are pointing to the picks and shovels of the AI picks and shovels. Companies like Constellation Energy, because nuclear power is absolutely going to become a massive, indispensable staple for powering these energy-hungry data centers around the clock. Companies like Vertiv, which specializes in the critical thermal management and cooling systems required to keep these insanely dense server racks from literally melting, and Bloom Energy, which provides on-site power generation, allowing data centers to operate completely independently of the slow-moving national grid. Bringing this all together,
All of this data points to a really straightforward win-win preparation strategy. It relies entirely on preparation rather than prediction. Step 1. Hold the fundamentally strong AI infrastructure layers, the NVIDIAs and Palantirs of the world that have true, proven economic moats. Step 2. Add these critical energy and cooling solution providers to the mix. By doing this, you are perfectly positioned to win regardless of the timeline. If the energy bottleneck takes 10 years to solve, your energy stocks thrive. If the bottleneck resolves much faster than expected, well, the data suggests your AI infrastructure stocks will see substantial continued growth. The bears are out there every single day fighting math with a narrative of fear. They use words like bubble to describe some of the most fundamentally strong, cash-generating businesses in modern history, completely missing where the real challenges and opportunities actually lie. So the final question you have to ask yourself is this. When everyone else is panicking, will you blindly follow the mainstream narrative, or will you follow the math? Because whenever narrative goes head-to-head against math, math always wins. Thanks for joining me on this explainer, and I'll catch you in the next one.